Hello and welcome back. This is going to be our last unit of chemistry for Survey of Biology, and in this unit we're going to kind of try to wrap up a lot of things that we've learned about valence electrons, the octet rule, and look at bonding, specifically covalent and ionic bonding, and how they rely on the properties of the individual elements to join together and form bonds. So we'll start with covalent bonding, and if you look at the actual name, cooperation together, and valence. So literally, the valence electrons are being shared, and that's exactly what a covalent bond is. It's the sharing of the valence electrons. So if we look at this very simple example on the board here of hydrogen, each hydrogen has one valence electron. And as if you remember, on the inner shell, how many electrons can they hold? 2 at the most. So in this case, they'd each like to gain one, but neither of them wants to give up the one they have. So what will happen is they end up sharing those 2 electrons and making a hydrogen molecule. So hydrogen is one of these elements that when they occur naturally, they are what we call diatomic, which means that there are 2 of them bound together. And the diatomic ones that you should be familiar with because of the biological significance are going to be nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So if you look on the periodic table in the upper right-hand corner, it makes an upside-down L from nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen has to be included in there as well, as we just saw. So all of these elements are going to be diatomic if they occur by themselves. So a quick review, if we look at the octet rule, so atoms are most stable if they have a filled or empty outer layer of electrons. So they're trying to achieve an octet. So with the exception of hydrogen and helium, which only need 2 because of the size of the inner shell, a filled layer contains 8 electrons, an octet. So atoms will gain or lose to become an ionic compound and form ionic bonds, or they may share, as we just saw with hydrogen, to become covalent compounds. So they want to get to their outer shell one way or the other. So here's an example in the upper left. Here's an oxygen atom. You can't really tell it's oxygen, but let's look at how oxygen may be formed as we go through and look at the valence electrons. So if we take oxygen and we look on the periodic table, we count over 1, 2, 3, 4, 5, 6. We find out that oxygen has 6 valence electrons. So I'm going to put oxygen in the middle, and that O is for oxygen, not the inner shell. So it has 2 electrons on the inner shell, and it has 1, 2, 3, 4, 5, 6 valence electrons. So it has 2 unpaired. And now if we take a second oxygen, again that's an O for oxygen, the inner shell we said has 2 electrons. The outer shell again has 1. Hang on a second here, guys. Sorry about this. Let's see if I can undo that. There we go. And we'll start over. So it has 1, 2, 3, 4, 5, 6 valence electrons as well. So now six valence electrons. How many additional electrons would each oxygen like to get? Well, they've got 6, they'd like to get to 8, so they each need 2, but they also don't want to give up any of the ones that they have. So what will end up happening is they will end up sharing those unpaired electrons. And so what we get if I show just the valence or outer shell electrons is we will get what's called a double bond. So we will actually have 4 of the electrons being shared with oxygen, and then we've got the additional paired electrons. So if we look at each individual oxygen, we have 1, 2, 3, 4, 5, 6, 7, 8 for the one on the left. But we also have 1, 2, 3, 4, 5, 6, 7, 8 electrons for the one on the right. So by sharing, they each achieve their octet in that way. And now let's look at the same thing. So another diatomic molecule is nitrogen. And let's look at, again, just the valence electrons. So nitrogen has 5 valence electrons. So I'm not going to show the inner layer of 2. 1, 2, 3, 4, 5. So how many additional electrons would nitrogen want to gain? As you can count, there's going to be 3 unpaired electrons, so we'd like to gain 3. Let's take a second nitrogen, and again, I'm just going to show the valence electrons. 1, 2, 3, 4, 5 valence electrons, and again, it would like to get 3 additional, but it doesn't want to give up any that we have. So if we were to look at this, what can you see happen? The way I've drawn it, it should be pretty straightforward that we're going to share, make 1 pair there. We're going to share a second pair here and a third pair right here. So if we were to draw nitrogen in its diatomic form, there would be a triple bond and a lone pair on each nitrogen. If I go back for just a second, if I can, to oxygen, what kind of bond formed here? Well, we're sharing 2 pairs, so oxygen will be a double bond with 2 lone pairs each. So let's go back to the nitrogen. And just remember that each bond, each line represents 2 electrons. So in the bonds here, we have 2, 4, 6, plus the lone electrons, 8. Each nitrogen has 8 electrons. So there's how we can show covalent bonds between there. And let's look at one last example. So here's one that's not diatomic. So here's carbon dioxide, which you all know of. And so let's go, and again, I'm just going to show the valence electrons, and I'm going to do it in Lewis dot format. So I'm going to put carbon in the middle, and I'm going to go 1, 2, 3, 4. So carbon has its 4 electrons. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. Now, how many additional electrons does carbon want? Well, it wants to gain 2 more. Where do you think they can come from? Well, let's look right here, and those 2 electrons, one from carbon, one from oxygen, can form. And what happens if we take this electron here and this electron there and slide them up so that we get here and here and form a bond right there, and then we can get rid of here and this. And so now by sliding those electrons, we've just formed a double bond between the carbon and the oxygen. Now let's go and look at the second oxygen over here, and I'm betting you've got a good idea as to what might happen over here. So first off, we'll pair up those unpaired ones right there, and then let's move electrons around a little bit. And so if we do that, we're going to get electrons coming here and here, and we'll form a bond right there. Let's go back and get rid of those. And there is carbon dioxide. So you can see a double bond forms between each of those. And we're going to move right along to, and the second one is going to be ionic bonds. So ionic bonds involves not the sharing of electrons, but the transfer of electrons. So it transfers electrons to create ions. And those ions are going to be called cations, which are positive, or anions, which are going to be negative. And those will then be attracted to each other because we know opposites attract. So an ion is an atom that has gained or lost an electron. It's also called a charged particle. So here's an example of an atom with a spare electron. It only has one electron in its outer shell. And here's one that needs one, so it already had 1, 2, 3, 4, 5, 6, 7. And we know because of our octet rule, if it gets an eighth, it will become very stable. So this electron on the, this atom on the left will give up a negative charge. It will become a positively charged cation. The one on the right will gain an electron. It will become negatively charged, and it will become an anion. So here's the case of sodium. Sodium has an atomic number of 11, so it has 11 protons. It also has 11 electrons, but only has one valence electron. And that's unstable, and it will give it up. So it will give up this electron and become sodium, and because it gave up a negative charge, it has one extra proton, so it becomes positive 1. Now here's a case of sodium chloride. Sodium, we saw before, has that one valence electron that it's willing to give up. Chlorine, on the other hand, already has 7. It doesn't want to give up any. It would like to gain one, if anything. So it will gain that electron that sodium gives up. It will become stable, and it will become negatively charged. So the positively charged sodium, the negatively charged chloride ion are attracted to each other. So that gives us sodium chloride, which we know as salt. So that's how sodium and chlorine can form salt, through an ionic bond. And here is just a cartoon version of it that you can see. So sodium will give up its one valence electron to become positively charged. Chlorine becomes negatively charged, and they're attracted to each other. So rather than sharing electrons, they're attracted to each other because of the difference in charges. So let's look at a different one here. Let's look at sodium oxide, and it's Na2O. Well, each sodium, we know, only has one valence electron. So I'm only going to show the valence electrons. And oxygen, as we've seen before, has 6 valence electrons. So how many electrons does the oxygen need to gain? Well, it needs to gain 2. Where can it get them from? Well, it can get 1 from one sodium, but it's still not stable yet. So it needs a second sodium to donate that electron there. And so what we end up with is each sodium becomes positively charged. The oxygen, because it's gained 2 negative electrons, becomes -2, and they cancel each other out. So ionic compounds are electrically neutral. So the positive and the negative charges have to cancel out. And there we go. There's the end of our chemistry for Survey of Biology. And I hope you've enjoyed it, or at least understood it. And we will talk with you soon.